The blimp is filled with exactly 400 cubic meters of helium. How big is the payload that the balloon can lift? So I got the density of the air, I've got the density of the helium, and it says to ignore the actual mass of the empty blimp. So since I'm talking about lifting the blimp, I'm talking about a buoyant force here. So I'm going to start with the free body diagram. So I've got my object, and I've got to lift up the weight of the helium, and I've got to lift up the weight of the payload, and I've got to lift up the weight of the blimp structure itself, the thing that's holding it all together. Except the problem says to ignore the mass of the blimp, so I'm actually going to get rid of that. And all that's being held up by the buoyant force of the blimp itself in the air. Since it's not changing velocity, there's no net acceleration to deal with, there's no net force. So all these forces are going to balance out because it's not changing velocity. So I'll sum up the forces in the y direction, and since it's not changing velocity, all that's going to be equal to 0. So that's the buoyant force minus the weight of the helium minus the weight of the payload. So therefore the weight of the payload is equal to the buoyant force minus the weight of the helium. So let's see, the buoyant force is rho vg, so that's rho the air volume of the blimp that's in the air, and g minus the weight of the helium. Since the whole blimp is in the air and the whole blimp is submerged, I'm going to use the whole volume of the blimp. The weight of the payload is equal to the density of the air times the volume times gravity is equal to mass mg, so that's mass of the helium times g. And I'm doing that because they gave me the density of the helium, and I've got to use the density to figure out what the mass is. So now rho vg for the blimp's buoyant force is equal to rho vg for the helium. So that's going to be the density of the helium times the volume times the gravity. The difference is the first one is the buoyant force, which is defined as the displacement of the fluid that you're in. That's the air. That's why that's density of air for the buoyant force. But on the second problem, it looks like the same thing, and it's not. It's the fact that what I'm trying to do is figure out the weight of the helium inside the blimp itself. So rho v is the weight of the helium, and g is gravity. I can put in my numbers, and when I do all that, I get the weight of the payload to be 4,351 newtons. Since they're asking for weight, and weight's a force, I know that my units are going to be in newtons. So it's tempting to convert it over to mass and get kilograms, but that wouldn't be right, since it's asking for the weight.